Hello everyone, today we're going to present about our MCA project, our project based on IoT car parking system. So basically, IR sensor will place on the ground to detect the presence of the vehicles in the parking lots. Each parking lot has one sensor in the midpoint to get information whether the parking is occupied or not. All the updates will send to the cloud and mobile app. These cloud information are used to honor for the parking management. These are the flowchart of our program. First of all, based on the block diagram, the IR sensor will send the information to ESP32, and then it will send the information to the Firebase, which is cloud sensor, and then finally it will send the information to the mobile application. Based on the system flowchart, once the program gets started, the IR sensor receives information. Then the sensor sends the information to the cloud. The stored data sends to the mobile application afterwards. Then it will show whether the parking slots are available or not. When the slots are occupied, it shows red in color, and if the parking slots are available, it displays green color. These are the primary materials and components that we use in our project. First of all, we use ESP32 as a main application processor. Then we use IR sensor to detect our cars. And finally, we use push button to act as an emergency button. These are the methods that we use throughout our project. First of all, we build a schematic diagram. This schematic diagram contains of ESP32, 4 IR sensors and push buttons. We program the code in Arduino IDE. Firebase is set up real-time database to take the data of the sensor and push button. The phone app is created using MIT App Inventor. Then the power up ESP32 and run the phone app together to see the program output. So this is the picture of Arduino IDE which is we use for our program. When the emergency button is pushed, we can see the real-time database in our Firebase software. This is the schematic circuit which our design for our project. And finally, this is our GUI sketch of our project. It shows a real-time parking slot status and available for all type of phone and make easier for drivers to find our parking space easily.
Okay. This is our project for the course MCA. So we have come out with the idea of making a IoT based parking lot system. So in this project, we have used the ESP32 as our microcontroller. So these are the connection for the breadboard, the circuit for the project. So basically this project consists of 4 sensors. So each sensors represent a parking lot. So this is sensor 1, sensor 2, sensor 3 and sensor 4, where this is the application on the phone that we did based on Firebase. So you can see here, this is the sensor 1 which represent the parking slot 1. So now the sensor is not detecting anything, which means the parking lot is available. So now when I close the sensor, when it detects something, you can see here the parking lot turns red, which means the parking lot is occupied. So these are for the sensor 2. These are for sensor 3, which is the parking lot system 3. And this is the parking lot number 4. Okay, so in our project, we also have used actuator. So the actuator here is a push button. So when I press the push button here in the circuit, there will a notification pop out in our application. So here's the notification that showing that the emergency button telling that our parking lot has an emergency situation going on. So this is the
Firebase. This is our Firebase system. So we use a real-time database for this application. So this one is our B1, U1, U2, U3 and U4. B1 represents the emergency button. U1 is for the parking sensor 1. U2 is for parking sensor 2. U3 is for parking sensor 3 and U4 is for parking sensor 4. So this 0 and 1 represents the sensor is in high or low input. Conclusion: the IoT parking system project report highlights the innovative solution it brings to traditional parking management system. It utilizes IoT technologies, real-time data monitoring, and intelligent algorithms to improve the parking experience for drivers and operators. Key components include an IoT infrastructure, a user-friendly mobile app for parking information and reservation, and intelligent algorithms for optimized parking allocation. Real-world testing showed improved efficiency, reduced search time, enhanced user experiences, and increased revenue. IR sensors enable accurate detection, monitoring, guidance, and security measures, while an emergency button enhances safety. The project contributes to Smart City initiative and has a potential to alleviate congestion, improve urban mobility, and faster sustainable transportation. Overall, it successfully achieved its objective and offers promising prospect for IoT-based parking management transformation. Thank you.